on this.
Sir, I have a question.
Yep.
I found it confusing because in high school we learned that tension on ropes is cancel out each other. So what I'm asking is when does a tension of rope cancel each other, and when does it account into calculations?
Okay.
Thank you, sir.
If you are talking about the rope itself, normally it will cancel each other. Yes, correct. Like what I draw here, right? In this particular part, it will cancel each other. Because when we draw the rope, it will be like this, and there will be a tension here and tension here. Correct, right? It will be canceling each other. But if we draw the other free body diagram, okay, if we draw the other free body diagram, not including the rope, and making the rope as just the external force, then in that case, most of the time it will not be canceling each other. Like this, for example. This one, I only draw the pulley, right? And this one as well, I only draw the pulley. You can see there that there is a tension because of the rope, but I do not draw the rope. I only draw the tension, the force due to the rope. And it will not be canceling each other, right? Do you get it?
So the T1, the tension on the horizontal axis, which connects the first pulley and the second pulley cancel out each other.
Sorry, the T1.
The T1 from the which connects both the pulley.
Yes, of course. If you draw the hole, right? If you draw the rope only there between pulley 1 and pulley 2 here, the rope only, it will be just like this, right? This is the rope, and there will be T1 here and T1 here, right? It will be canceling each other, of course, right? Do you get it?
Okay, how about the third pulley on the edge of the uniform beam?
In that case, then the pulley will be slightly different in that case. Okay. It will be like this. If you draw just the pulley, right, and separate it from the rest, then what we will have is there will be a T, there will be tension force here, T, and there will be tension here, T, and there will be reaction. What you call that? IUC, okay, D, dy, dx, something like that. Okay, but remember, this one is part of the internal force. Okay, but if you want to separate that particle pulley with to the system, then this is what will come out. Okay. Yeah. Okay, do you get it? Hello?
Yes, sir. Thank you.
About this particular problem, do you have any, and do you guys have any problem here? I think I will try to draw this so it will interconnect to each other, okay? In order to make you not confusing about the free body diagram. Okay. I will just try to make it smaller in order for us to be able to draw the free body diagram here. Okay. Reinhard Rema. Hello, Reinhard?
Yes, sir.
Do you understand about the previous problem that we talked about?
Number 3 or number 4?
Number three.
Yes, I understand, sir.
Okay, good. Muhammad Hilmi, apakah dipahami yang ini? Oke. Jadi tinggal masalah kita apa namanya mengisolasi permasalahannya yang ini ya. Jadi di sini kalau kita bisa isolasi dia orangnya plus rope yang ada di sini, ya, rope yang ada di sini plus beamnya itu jadi satu sistem, diagram badai bebas kita jadi seperti ini. Ya, ini kita bisa selesaikan langsung karena ada 3 persamaan, 3 unknown seperti itu. Oke. Nah, untuk kasus yang ini agak sedikit berbeda. Oke. For this particular problem is slightly different. What is asked here is, wait a minute. Hide notification. With what force magnitude T must be person pull on the cable in order to cause the scale A to read 500 lbf. Okay. The weight of the pulleys and cables are negligible. State any assumption. Okay. So basically, what we want to do is to find out that to find out the pulling force here, T, pulling force, the tension force there, T, that must the person give to the rope there, in order for us to get the reading here is the reading at the weighing machine there, 500 lbf. But remember, the actual weight there is actually 1000 lbf. So how can we do it that way? So basically, the first thing that we're supposed to draw is the weight itself. Okay, the weight itself. The weight is 1000 lbf going downwards. Okay, and beside that, the reading of the machine is actually coming from the normal force here. Normal force from the weighing machine. Okay, the normal force from the weighing machine. And beside that, there is a tension there, here. Okay, I name it as T1. Okay, so basically this is the free body diagram of the weight there, the free body diagram of this particular system. Okay, in order for us to solve for this particular problem, hello? Halo Irsyad.
Halo sir, kepencet.
Okay. Okay, so from this particular problem, it is known that the value of n is supposed to be certain value here. Wait a minute. I think I will call one of you. Okay, Irsyad, because just now I saw, I heard you singing, right? I'm not sure whether it's you or somebody else behind you singing.
I think background noise. Hello sir.
Okay, but anyway, the normal force here is supposed to be what value, Irsyad?
1000.
1000? You sure 1000? Remember,
Wait.
okay, the scale
500.
supposed to read 500 lbf, right?
Yeah. 500,
So the normal
sorry.
force supposed to be 500, right? Because if we draw the free body diagram of the weighing machine, okay, in order for it to read 500 there, the normal force that is going down to the weighing machine is supposed to be 500, right?
Yes.
So N here is supposed to be 500 lbf, right? From this, can we find out T1, Irsyad?
Yes, it's just 500.
Yes. Just 500 because basically we just need to use sigma Fy, right? Equal to 0. Correct, right, Irsyad?
Yeah.
Okay. From this, what we will get is 1000 minus 500 minus T1 is equal to 0. So T1 will be equal to 500 L. Okay, then after that, Irshad, still Irshad, which
Yeah.
free body diagram that we're supposed to draw, Irshad?
I think we should draw the pulley next.
The pulley next to
The one.
1000. Okay.
Yeah, the one
So you
attached
mean
to.
you mean this one, right?
Yes.
Okay. Okay, so let's draw that particular pulley. Okay, so this is the pulley. What forces that we have there, Irshad?
There is T1 from the bottom.
Okay, T1 from the
And-
bottom. Okay, but
Yes.
now it's going up or going down?
Going down.
Going down because action and reaction. Okay, so this one is T1, and we know the value of T1, right? So you're supposed to put it there, 500 lbf, right? What else?
Yes.
Irshad?
There are two more tensions on the left and right,
Two more tension. Okay,
going up, both of them.
okay, then here we just assume that both are going up. Okay, because it's we don't know about the angle, right? So one of the assumption here is everything, all the tension force is given as a vertical. There is no angle there, so everything is vertical force. Okay, then
Yes.
what else?
There's like another smaller pulley that's attached to it. Does that count?
Yes, of course, it's supposed to be a count.
Oh, okay.
You're supposed to count that as well. So this one, I name it as T2. Okay. Then this one, I will name it as T3. Okay. And then there will be a bar there, right? This one is
Yeah.
some kind of a connection bar there. Okay. For that particular bar, what force that will be given to the pulley, to the downwards pulley there?
I think upward to. Oh, is that like a joint?
Join what?
A rotational joint, a fixed point joint.
Yeah,
am
a
I
fixed
wrong?
point joint, but actually there will be no horizontal force there. So there will be only vertical only. Okay.
Oh, okay.
See, what you call this? Okay, then I will call this as AY then. Okay, will you be able to solve for this?
No, there are three unknowns.
Three unknowns, and we only have how many equations here?
Only one.
Not one. We have two actually.
Okay, two. Yes. The
Sigma moment and
the
sigma
Y.
Fy. Okay.
Yes.
Sigma moment equal to 0 and sigma Fy equal to 0. So we will not be able to solve that. Okay. Using sigma moment at A equal to 0, what we will get there? Sigma moment here equal to 0. What we will get?
500 minus AY.
Sorry?
A minus. Oh.
No. Here. The
Oh.
center is here.
No, just 0. There is no horizontal force.
There is no horizontal force, but I want to use sigma moment at A equal to 0. Sigma moment at that particular point equal to 0. What we will get there? Irshad.
I'm not quite sure. So
The one that is not going to the center is what? Because remember,
T3
A
and
is here.
T2.
Yeah, T2 and T3, right? T2 multiplied by the radius minus T3 multiplied by
Oh,
radius equal to 0,
yeah.
right? Correct, right?
Yes, yes.
So what's the
I
result?
just realized. So,
This one is T2 multiplied by radius minus T3 multiplied by
three,
radius equal to 0. So what you will get?
0.
T2 equal to T3, right? Always that
Oh,
way, right?
yes.
Right? Whenever you have a
Correct.
pulley, right? Normally, if the pulley is frictionless, the tension force that is going to that pulley from one side and the other side will be the same. Okay, Rishad? Because of that, because of sigma moment at the center. Okay, Rishad?
Yes.
Okay, T2 and T3 is the same. Now, which free body diagram that we're supposed to go next then?
Mm, the one in the middle of the two pulleys.
The one in the middle of the two pulleys, you mean this?
Yes.
Okay. I think it's better for us to not going there first, but it's better for us to going for this one because
Okay.
we have T2 there, right? So let's draw for that one, but that particular free body diagram. So we will draw this, right? That one we have T2 going downwards, right? Here, correct, correct?
Yes.
Okay, and then we have T4 here going downwards.
Is it the same as T2 again?
Yes, of course, using sigma moment in the middle, right? But
Okay.
this one we have a reaction force. Maybe we call it as Py. Okay, Py and Px actually, yeah, there is a Ay and Ax. Yes, you're supposed to draw a y here and Ax as well. It's safer that way, but Ax will be 0, the same as this one. Yeah, Px will be 0, right? Okay.
Yes.
From this one, using sigma moment at B equal to 0, what you will get is T4 is equal to T2, correct, right?
Yes.
Okay, now we know that T4 is equal to T2. Okay. Then this one is T2, this one is T4. Okay. Then we the rope here is going to the one at the bottom, right? Yeah. Now that's the next thing that we're supposed to draw. This one. Okay, this one. What forces that we have there?
T4 and T5 now.
Oh, yes. T4 going up, right? And T5 going up as well. And there we have Cx, Cy. As usual, Cy, Cx. Okay. And as usual, okay, as usual, this one, okay, as usual, using sigma moment at C equal to 0, we can find that T4 is equal to T5, correct, right?
Yeah.
Now the last one that we have to solve is this one. What we have there? T5, right?
T5 and T6 going down.
T5, T6, both are going down. And we have dy and dx. Okay, the same here. Using sigma moment at t equal to 0, what we will have is T6 equal to T5, right? Okay.
Yes.
Now let's try to solve everything right now. Okay. This one here, we are connecting to 1, 2. We know there is T2 equal to T3. Then after that, T2 is equal to T4. Okay. Then after that, T4 is equal to T5 and T6 equal to T5. Okay, so see this one here, basically we have T2 equal to T3 equal to T4 equal to T5 equal to T6, right? Right?
Yes.
Okay, so now try to take a look at this this particular free body diagram. Okay, this one is actually a little bit the forces there is actually a little bit wrong, because actually we have T going up here, right? It's supposed to be
T6, right?
T6 here, right?
Yeah.
Okay. So we have T6 over there, okay? And remember, CY here actually is connected to the AY here, right? So actually that one is not supposed to be CY. Using this one is AY.
Way down.
Yeah, this one is AY as well. This one is supposed to be AY going down. Okay. So using sigma fx equal to 0 here, Cx will be 0, right?
Yes, because it doesn't move.
And now AY, we will know the value of AY using sigma fx equal to 0, right? And AY there will be the summation of T4, T6, and T5, correct?
T4 and T6.
And T5, right? Everything is going
Oh,
up.
yes, yes.
Yeah. So
Yes.
AY will be T4 plus T6 plus T5. Okay. Now let's take a look at this particular free body diagram. AY there is going up, right? And it's supposed to be the same as T4 plus T6 plus T5. Okay. Can we find out the value of T2, T3, T4, T6, and T5 there? Remember that we have here, everything are the same, right?
Yeah.
And using sigma Fy here, what you will be getting there?
T3 plus T2 plus
Plus
AY.
Yeah. T3 plus T2 plus AY
Equals
minus T1, right?
Oh, yeah,
Equal to 0, right? Yep.
Yes.
T1 is 500, but AY is equal to this, right?
And then we can slot it in.
Yes, correct. You can slot it in. So T1 will be equal to T2 plus T3 plus T4 plus T5 plus T6.
Well, T is 100.
Yes, this one, all three here, we call it as T, okay? It's supposed to be 100 because this one is 500, right?
Yes.
LBF. So it's equal to
5T.
T, yeah, 5T. So T will be equal to 100 LBF. If T is 100 LBF, then T3 is 100 LBF, right? T3 is this one. And using this particular pulley, okay, it will be T3 and it will be T7, right? T7 is the question.
Yes.
So it's supposed to be 100 as well, right?
Yeah. We don't divide this one by 2.
Yeah, why we divide it by 2?
The sigma fy. Wait.
No, you just use sigma moment.
Oh yeah.
Sigma moment at E equal to 0. Then you will get that T3 will be equal to T7. T3 is 100, T7 will be 100 lbf, right?
Oh right. Yes. Yes.
Yeah. So the answer is the tension that's supposed to be given there is
100.
100 lbf. You get it, right? So this is the way to draw
Yes.
the free body diagram, so it will interconnect to each other. Okay, I believe it answers one of the question of your friend, like just now, William, if I'm not mistaken, right, William? Okay, if we draw it, okay, we don't have to draw the tension, we don't have to draw the rope, but we draw the force due to the tension, the force due to the rope, like that. So we can draw the free body diagram, so it will interconnect to each other like this, action and reaction. Okay.
Sir.
Mm-hmm.
So if the instruction is for us to draw all the free body diagram, so if there were 5, for example, 5 pulleys, so we draw 5 different free body diagrams.
Oh yes, of course.
Okay, thank you.
The way to do it is this way actually to solve this one. Okay. Is it understood, William?
Yes, sir. Thank you. Do you mind solving the number 3 questions as well?
Sorry.
Do you mind working on the problem number 3 as well?
Solving number 3. Just now we solve it, right?
No, I mean until we have the final answer.
Okay. That one I don't have time to solve this one. So basically, as long as you solve this, okay, as long as you solve this, okay, using this free body diagram, I believe you will be able to solve it correctly. Okay, because all the dimensions are there already. This one is 5. This one is 4 feet, right? This one is 2 feet, 6 feet, and 2 feet. So all the dimensions are there, correct, right? So I believe you will be able to solve for OY, OX, AY using this particular free body diagram. Okay. Hello, William?
Yes, sir. Sure.
It's not supposed to be a problem. So the first thing that you're supposed to do is to use sigma moment at O equal to 0, okay, to find AY. And after that, using sigma Fy equal to 0 to find OY. And then using sigma Fx equal to 0 to find OX. OX supposed to be 0 then. Okay?
Yeah, sure. Thank you, sir.
The results OX supposed to be 0, but AY and OY both are not supposed to be 0. Okay. I believe this is your homework, and I believe it's supposed to be clear enough for you guys. Okay. The next for today, I will concentrate on practice. Tomorrow, I'm not sure. Okay, the quiz can be at the beginning of the class or can be at the end of the class as well. So starting from this week, okay, actually starting from last week, right? On Friday, instead of using the class for only 1 hour, I will be using the class for at least 1.5 hours, okay, for Friday. Why? Because if I'm not mistaken, right, on the 3rd of wait a minute, on the 3rd, yeah, 3rd of March, on the 3rd of March, Thursday will be holiday, and Thursday is actually 2 hours of our class. So in order in order to not adding any additional class, okay, starting from last week, I will use our Friday. Okay, I will use our Friday instead of just using it for 1 hour. I will use it for 1.5 hours. Is it understood, guys? Hello, hello, hello.
Yes, sir, that's okay.
Yeah.
Yes, sir.
Should be okay, right? Because if I'm not mistaken, you have some of you have a lab class, but at 9, right? If I'm not mistaken. So should be okay to prolong it a bit until 8:30 in the morning, right? So every Friday, I will add another 30 minutes in our class. And for tomorrow, I'm not sure yet whether I will put the quiz at the beginning of the class, which means we will start the quiz at 7, or I will put it at the end of the class, which means that I will start the quiz at 8 till 8:30, like that. Okay, so for tomorrow, it's either of those two. So please come to the class at 7 in the morning. Okay, is it understood for tomorrow? So we will have, for sure, we will have quiz tomorrow, and the quiz is about equilibrium. Okay. Keep. Okay, I will start with another problem example. Okay, because for today I will give several problem example. So this one is too simple. I think I will do it with this one, and then after that I will give problem example which is given in our previous exam. Okay, wait a minute. I think I will add it here first. Okay, there are two problems that I will discuss today. After this, one of which is the exam from several years ago, or last year. Get the exam of last year's, and the other is another problem that we're supposed to discuss about. Okay, this one. Wait a minute. Have I shared it with you? Not yet. Not yet. Okay, this one. Can you share? Can you see my my PowerPoint?
Yes, sir.
So this is the problem. Okay, so basically, there is a small frame which is mounted on one side of the bed of the pickup truck, and the shape is like this. The condition is like this. Okay, theta there is 40 degrees. Okay, theta there is 40 degrees, and we supposed to determine the magnitude of the force supported by the pin at O. Okay, supported by the pin at O, and the oil pressure P against the 50 millimeter diameter piston of the hydraulic cylinder PC. Okay. For this one, I will ask Muhammad Hilmi. Halo, Muhammad Hilmi.
Ya, Pak.
Untuk yang soal sebelumnya, kamu paham tidak, Hilmi?
Masih paham, Pak.
Cukup paham ya berarti ya, yang masalah puli apa? Sistem puli seperti itu harusnya nggak ada masalah ya, Hilmi?
Iya, Pak.
Nah, sekarang saya minta tolong kamu, Hilmi. Untuk kasus ini, penyelesaiannya bagaimana, Hilmi? Yang diminta itu adalah gaya yang terjadi pada titik O, gaya-gaya pada pin O, dan juga besar pressure P pada hidrolik di silinder BC. Seperti itu, Hilmi. Untuk menyelesaikan ini bagaimana, Hilmi?
Gambar pribadinya dulu, Pak.
Kita mulai dengan gambar diagram benda bebasnya, oke? Gambar diagram benda bebasnya yang kita gambarnya itu, yang kita gambar sebaiknya sistem yang mana, Hilmi?
Small crane-nya.
Yang mana?
Small crane-nya, Pak.
Small crane-nya itu yang mana? Kamu bisa annotate nggak? Sebentar. Small crane itu yang mana?
Yang ini, Pak.
Small crane-nya. Oke. Sebenarnya bisa seperti itu ya. Tetapi ada yang lebih simpel lagi, Helmi. Oke. Di sini, nih ya, yang saya coba tanyakan, Helmi. Bagian ini, bagian titik B ini, apakah ditanyakan reaksi yang terjadi di sana atau tidak?
Tidak, Pak.
Nggak ditanyakan ya. Kalau kayak gitu, kenapa harus yang sisi bawahnya kita gambar? Bisa tidak kalau sistem yang kita gambar cuma ini saja? Di mana BC itu bekerja sebagai gaya luar. Bisa nggak?
Bisa, Pak.
Bisa ya. Nah, sebelum ke sana, ini mungkin saya coba sebelum ke sana, sebentar. Saya coba share dulu masalah equilibrium ya. Oke. Nah, terkait dengan kasus-kasus yang kita temui, kadang-kadang kita berhadapan dengan yang namanya two force member ini. Kadang-kadang kita berhadapan dengan yang namanya multi force member. Okay, so when we talk about the free body diagram, any free body diagram, sometimes we will face two force member, sometimes we will face multi force member. Okay, so what is the sign of a two force member? Actually, when we talk about this, ya, belum lupa di share. Okay. Okay, when we talk about this, actually, this one involves a multi-force member and a two-force member. Oke, bisa dilihat di sini bahwa ini ada two force member-nya, tetapi juga ada multi force member ya. Ya. Nah, apa perbedaan antara two force member dengan multi force member? What is the difference between two force member and multi force member? Okay. When we talk about two force member, it is only supported at both ends with pin, but frictionless pin. Seperti ini ya. Ini adalah contoh two force member. Jadi dia itu ditahan di ujung-ujungnya dengan menggunakan pin, tetapi frictionless pin di situ. Nah, apa spesialnya dengan two force member? Apa spesialnya two force member? Apa spesialnya multi force member? Oke, kalau two force member itu biasanya dia hanya kalau tidak tarik atau tekan saja. Oke, gaya-gaya yang bekerja pada dia kalau nggak tarik ya tekan saja. Kalau itu two force member. Oke, for two force member, what is special about two force member? When we talk about two force member, normally it's either under tension or under compression only. There will be no bending there because the force is only given at both ends only. Okay, the force only given at both ends. In this one, this is a my drawing is very bad. Okay, when we talk about a member like that, and the member is only supported at both ends with pin, frictionless pin, there will be no bending there. So either the member will be under tension like this, or under compression like this. Okay, we call that as two force member. Okay, when we talk about a system, okay, when we talk about structure like that, okay, there is sometimes we have to face this kind of member, two force member, but most of the time we will face multi-force member like this. Multi-force member, the sign of multi-force member is not necessarily the force only happening at both ends only, but sometimes in the middle we have another external force like this one, like the AO member, ACO member. Okay, ACO member, if you draw it, okay, there is a force like this, then at C there is like this, then like this. Okay, so at O there is OY and OX, and then at C there is force there at C, external force there, and at A there is a force as well. Okay, so the force which is happening to this particular member is not just at both ends like this. We call this kind of a member, we call this kind of member as multi-force member. This kind of member, we call it as two force member. Okay. So basically, if it's not two force member, most of the time it will be multi-force member. So what you need to know is how to determine which part of it is two force member, and how to determine whether some one member is a two force member or not is just by taking a look at the force where the force is given. If the force is given only at both ends like this, okay, it must be two force member. So this is the example. This is the easiest example. Okay, member CB. Member CB is most likely two force member. Why? Because it's only given force at one end C and the other end B, like that. Okay, so it must be two force member. Okay. Anyone here want to ask question about this? Hello, hello, hello.
Sir,
Yes.
could you repeat what you meant by multi-force member?
Okay. So when we talk about multi-force member, it means a member which the force is not only happening at both ends. So beside two force member, all other type of member, we call it as multi-force member. That's very simple. So multi-force member is the other type of member beside two force member. So what you need to know is just how to determine, how to differentiate between two force member and the other type of member. Jadi jenis dari batang itu ada dua jenis batang ya. Yang pertama adalah batang dua gaya, two force member. Bagaimana cara mengetahui bahwa suatu batang itu batang dua gaya atau tidak? Itu coba dilihat. Gaya-gaya yang terjadi pada dia hanya di ujung-ujungnya saja atau tidak. Oke, kalau misalkan gaya-gaya yang terjadi pada dia hanya di ujung-ujungnya saja, kita sebut itu sebagai batang dua gaya. Oke, tetapi kalau misalkan pada suatu batang, gaya yang bekerja itu tidak hanya ada di ujung-ujungnya. Sebagai contoh, misalkan batang ACO di sini. Batang ACO itu bukan batang dua gaya. Ya, batang ACO itu bukan batang dua gaya. Kita bisa lihat kalau saya gambarkan diagram grafikasnya batang ACO. Itu gaya-gaya yang terjadi pada dia seperti ini. Ada AY di sini, kemudian ada FCB di sini, ada OY, OX di sana. Ada banyak gaya yang bekerja di sana. Dan tidak hanya di ujung-ujungnya saja. Jadi ini bukan batang dua gaya. Seperti itu. Ini multi-force member. Ini batang banyak gaya. Ya, jadi itu cara membedakan antara batang dua gaya dengan batang banyak gaya. Seperti itu. Nah, apa yang spesial dari batang dua gaya? Batang dua gaya itu opsinya itu cuman dia kalau tidak tarik, ya tekan. Jadi gaya yang bekerja pada batang tersebut, okay, gaya yang bekerja pada batang dua gaya itu selalu segaris kerja dengan si batang tersebut. Selalu segaris kerja dengan si batang tersebut, kecuali pada beberapa kasus khusus ya. Selalu segaris kerja dengan batang tersebut. Dan opsinya kalau tidak batang itu batang tarik, ya batang tekan. Gaya-gaya yang terjadi kalau tidak tarik seperti ini, ya tekan seperti itu. Seperti itu. Itu adalah batang dua gaya. Sampai di sini apakah dipahami?
Yeah, so the two force member, the force that acts on a two force member is like collinear, right?
Yep, collinear, and it's happening at both ends only. So that's the way to differentiate that with the other type of member. So you can see here, right? CB is actually two force member. Why? Why I can say that? Because the force is only happening at point C and point B, right? At both ends only, and it is not stated there that C and B is has a friction. So it's frictionless. We can call it as frictionless. When it's frictionless and it's happening at both ends, it must be two force member. Do you get it?
Yes, sir.
Okay, good, Amadia. Tadi yang saya mana tadi? Ini ya. Tadi yang saya panggil itu adalah sebentar. Tadi itu yang sebelumnya saya panggil siapa ya?
Saya,
Hilmi, oke, Hilmi. Hilmi, apakah sudah dipahami?
ya, Pak.
Oke. Nah, sekarang untuk menyelesaikan kasus ini, oke, kita sudah tahu kan ya bahwa batang CB itu adalah batang dua gaya kan ya, Hilmi?
Ya.
Betul kan? Batang CB itu batang dua gaya. Jadi kalau kita gambarkan batang CB seperti ini, dia antara mengalami tarik seperti ini atau mengalami tekan seperti ini. Gitu ya ilmiah. Tetapi kita bisa asumsikan bahwa gaya yang disebabkan oleh batang CB itu searah dengan garis kerja dari batang tersebut. Kebayang ya Hilmi? Halo Hilmi? Paham ya Hilmi?
Tapi kalau yang atasnya neken, bawahnya
kita nggak usah tahu dulu, tekan tariknya nggak usah tahu dulu. Oke, yang penting kita definisikan bahwa gaya yang bekerja pada dia itu searah dengan batangnya. Kebayang nggak Hilmi?
Ya, kebayang.
Nah, karena itu saya bisa sederhanakan si batang CB ini. Ini saya bisa sederhanakan. Saya ganti dia jadi gaya searah dengan gaya searah dengan batangnya. Boleh kan ya? Karena pasti arah gayanya searah dengan batangnya kan? Betul kan?
Ya.
Nah, itu spesialnya batang dua gaya. Saat kita tahu dia itu batang dua gaya, kita bisa sederhanakan dia, hilangkan batangnya, ganti dengan gaya yang searah dengan batangnya. Jadi saya gambarkan batang CB di sini, representasinya adalah FCB ini. Yang searah dengan batangnya. Kebayang nggak? Halo, halo?
Ya, halo.
Halo?
Ya, halo.
Jadi saya bisa sederhanakan tadi kasus ini, ya, yang tadi awalnya kamu mau gambar free body diagramnya itu keseluruhan seperti ini kan ya? Ini saya bisa sederhanakan, saya nggak mau gambar keseluruhan, yang saya gambar cuman batang ACO saja. Oke, lalu batang ACO itu tetapi mendapatkan gaya OXOY di ujungnya plus gaya FCB di C. Paham nggak?
Ya.
Nah, gaya FCB itu searah dengan garis kerja batangnya. Paham kan?
Ya.
Oke. Nah, kalau misalkan diagram bebasnya seperti ini, apakah bisa diselesaikan atau tidak? Nilai dari AY itu berapa ya?
Hmm. 120 dikali gravitasi.
Gravitasi, oke ya. AY itu adalah 120 dikali gravitasi. Berarti kalau kita pakai G-nya 10 berarti 1200 lah ya, biar gampang. Tetapi kalau pas waktu ujian tolong pakai 9,81 ya. 1200 Newton di sini. Oke. Di sini kita punya berapa anons?
3.
3 anons. FCB, OY, OX kan ya. Kita punya berapa persamaan? Ilmi.
3.
3 juga. Kita punya 3 persamaan. Apa saja itu persamaannya?
Sigma M sama dengan 0. Sigma Fx sama dengan 0. Sigma Fy sama dengan 0.
Oke. Ya. Sigma momen sama dengan 0, sigma Fx sama dengan 0, sigma Fy sama dengan 0. Oke. Nah, sekarang mana dulu yang kamu pengen selesaikan di sini?
FCB.
FCB. FCB bisa kita selesaikan pakai persamaan yang mana?
Sigma MO.
Sigma M di titik O, betul sekali ya. Sigma M di titik O sama dengan 0. Itu kita bisa gunakan untuk menyelesaikan FCB. Sebentar, saya hapus dulu ya. Oke, sigma momen di O sama dengan 0. Kita bisa selesaikan FCB. Oke, hasilnya apa itu? Sigma momen sama dengan 0 itu. Persamaannya jadi kayak gimana?
1200.
1200. Ini yang diketahui sudutnya adalah 40 derajat ya. Di sini tetanya 40 derajat. Di sini tetanya 40 derajat.
Cos.
Cos. Cos berapa? Ini ya gambarnya paling
40
gampang kalau
derajat.
di sini 40 derajat. Di sini berapa?
Itu jadi
Segitiganya kan ini kan
50.
50, betul. Di situ jadi 50 derajat. Terus kamu ingin mencari apa yang tegak lurus terhadap batangnya kan?
Ya.
Berarti ini jadinya sudutnya berapa nih? Kamu mau pakai sin atau pakai cos? Terserah. Kalau pakai cos, ya berarti sudutnya yang ini.
Kalau cos 40.
Tuh, cos 40. Cos 40 derajat. Ini ya. Karena sudut di situ 40 derajat ya. (1200) cos 40 derajat itu arahnya di ke sini kan ya? Gitu. Oke, lengan momennya berapa?
1125.
1125, betul. 1125 mm. Ini Newtonnya. Oke. Lalu ada apa lagi di sana? Selain itu?
FCB, Pak.
FCB. Nah, FCB gimana tuh kalau FCB?
Oh,
Itu sudut-sudutnya memang agak nyebelin ya ini ya, FCB ya? Betul ya?
itu bisa
Segitiganya yang mana ini kalau FCB itu? Gimana Helmi? Ini yang nyebelin adalah sudutnya ya, kalau yang FCB itu. Karena tidak diketahui langsung, tetapi kita harus menggunakan geometri di sana. Oke, kita harus menggunakan geometri di sana untuk mencari tahu sudutnya. Oke, ini bentuknya itu seperti ini ya, berarti. Dari sini ke sini adalah 360, kemudian dari sini ke sini adalah 340, 40 derajat ya, di sini. Kemudian dari sini ke sini tegak lurus 110. Oke, lalu kita hubungkan dari sini ke sini. Kita bisa bikin segitiga apa itu dari situ? 360, 340, 110. Sudut di sini yang diketahui adalah 40 derajat. Gimana? Halo? Hilmi? Atau ada yang lain yang bisa membantu? Silakan. Kadang-kadang permasalahan statika itu harus menyelesaikan kasus-kasus geometri di sini. Seperti ini. Ini kan yang kita butuhkan adalah sudut di sini. Ini sudutnya berapa ini? Alfa di sini. Gimana Hilmi? Halo, halo, halo. Hilmi?
ya.
Gimana Hilmi? Nyerah kamu? Atau enggak? Coba ya, ini mungkin saya kasih clue ke kamu ya Hilmi ya. Ini kan tegak lurus ya 90 derajat. Oke. Bagian yang ini bisa apa? Bagian yang saya centang di situ itu bukannya bisa tinggal Pythagoras dari 340 sama 110 ya?
Iya, Pak.
Betul kan ya? Terus dari situ setelah dapat sisi miring, atau kalau misalkan tanpa dapat sisi miring, apa namanya? Setelah dapat sisi miringnya atau sebelum dapat sisi miringnya, itu kan kamu bisa tahu sudutnya kan ya? Sudut yang bagian kecil ini bisa tahu kan? Bisa nggak?
Iya,
Bisa kan ya?
Bisa.
Betul kan? Bisa tahu. Nah, kalau misalkan sudut di situ bisa tahu, terus sisi miringnya bisa tahu, sudut di sini juga bisa tahu kan? Bisa kan? Atau enggak?
Gimana, Pak?
Ini kan tinggal masalah geometri nih. Ini ada yang bisa membantu Hilmi atau tidak? Hilmi, yang menurut kamu matematikanya paling jago siapa di sini? Tunjuk aja satu.
Rehan, Pak.
Rehan, silakan Rehan. Gimana Rehan? Untuk mendapatkan sudutnya gimana tuh?
Kalau saya ini Pak, 90 dikurang artan 340 cos 40 per 360.
Itu dari mana? Jangan pakai keajaiban tiba-tiba gitu.
Enggak, itu kan yang atas itu saya mikirnya 340 cos 40, Pak.
340 gimana?
340 cos 40.
340 cos 40. Yang miringnya itu.
Bukan yang garis putus-putus itu, Pak.
Sebentar. Garis putus-putus ini ya. Bagian ini ya maksudmu? Itu 340 cos 40. Terus?
Nanti pemaketan sama 360-nya dapat sudut yang di segitiganya itu.
Sebentar, pertanyaan saya ini kalau misalkan kayak gitu. Sebentar ya. 340. Oh iya bisa betul. Maksud kamu gini ya?
Iya, Pak.
Kamu gitu kan langsung ya. 340 dikoskan sebentar. Dapat sebentar, kalau itu garis horizontal. Pertanyaan saya, apakah pasti di situ ya? Kalau misalkan dari itu 340 itu sisi miring dari si bagian horizontal itu pasti tidak?
Pasti kayaknya.
Kok kayaknya? Ini kamu yakin nggak tuh?
Yakin, Pak ya?
Yakin. 340 sebentar. 340 sudut sini. Ini kan di sini ya. 340 sudut situ sampai sini. Terus kok kelihatannya belum tentu ya itu ya. Itu kan berarti kan harusnya persyaratannya adalah si bagian horizontal ini pasti bawah persis dibanding ini kan ya. Itu belum tentu loh tuh. Yakin itu?
Berarti nggak bisa ya, Pak?
Enggak lah. Cuman ini masih bisa diselesaikan, tapi memang rada panjang. Bagaimana caranya coba? Ini karena kalau misalkan sudutnya sudah dapat, ini selesai. Benar kan ya? Hilmi gimana Hilmi? Atau ada lagi yang lain yang bisa membantu? Silakan. Jika ada yang lain yang bisa membantu, silakan. Sebenarnya gini, ini ya. Kalau paling gampang menurut saya itu kita punya 340 dan kita punya 110. Ini tadi Hilmi sama Raihan ya. Kita punya 340 sama 110. Kita pakai Pitagoras bisa dapat sisi miring kan ya? Betul? Hilmi, Raihan.
Betul, Pak.
Betul kan ya? Terus kita punya apa namanya? Kita punya sisi miring di sana. Kita tahu sisi miringnya ini kan ya? Berarti yang bagian ini kita tahu kan nilainya? Dari Pitagoras itu, betul nggak?
Iya.
Betul kan? Nah, setelah itu, sudut di sini juga kita bisa tahu kan? Sudut kecil itu. Karena kita punya 110 sama 340. Tangennya kan, tangannya itu kan 110 per 340. Betul tidak?
Oh iya. Iya.
Betul kan? Betul kan? Nah, kemudian dari horizontal sampai miring ini, itu kan 40 derajat. Dikurangi dari sudut itu kan jadinya sudut kecil ini kan ya? Ditambah 90 derajat itu jadi sudut ini kan? Betul nggak, Ryan?
Iya, Pak.
Betul kan? Kalau kita punya dua sisi plus satu sudut yang mengapit sisi tersebut, itu kan selesai kan harusnya segitiganya? Benar nggak? Betul tidak? Pakai rumus ABC itu loh, kebayang nggak? Halo, Raihan, Hilmi.
Gimana, Pak?
Pakai rumus ABC.
Pak.
Pakai rumus ABC. Jadi ini ya, kita sudah punya sisi bagian yang ini, kita sudah punya sisi miring yang 110 dan 340 tadi. Oke. Lalu kita punya sudut yang mengapit kedua sisi tersebut. Itu kan bisa kan? Selesai kan? Segitiganya? Iya nggak sih?
Iya.
Betul nggak, Raihan?
Betul, Pak.
Betul. Nah, rumusnya bagaimana tuh kalau untuk mendapatkan sisi satunya lagi?
360 kuadrat.
Ini pakai rumus ABC ya. Harusnya itu bisa didapat itu. Apa namanya? Yang pakai apa namanya? Kuadrat-kuadrat dari dua sisi tersebut terus ditambah atau dikurang tuh saya lupa ya. Dari yang kosinus atau sinus dari sudutnya itu. Ada kan ya itu rumusan seperti itu? Ini tinggal masalah apa namanya? Tinggal masalah geometri saja. Asalkan kita sudah mendapatkan sudut di sini, itu selesai. Betul kan? Betul kan, Ryan? Jelly? Ya?
Iya, Pak.
Seperti itu. Jadi dalam beberapa kasus pencarian sudut itu kadang-kadang memang menyebalkan. Ya, so in some cases, okay, the way to find the geometry, we have to use a complicated method to find the geometry. We have to use complicated method to find the angle. Sometimes we have to do that, and this is one of the case which we have to do it that way. Why? Because the angle there, in order to find the angle of FCB, is quite hard. Okay, you have to use the triangle method there. Okay, but once the FCB is known, everything will be much easier. Okay, any question here besides the geometry? I believe for this particular problem, in order for you to learn about the mathematics behind the problem, I will put this problem as one of your homework as well. Okay, so you can relearn about the geometric things. Okay, any question here? Naila, apakah masih ingat kamu, Naila? Bagaimana cara mencari sudutnya? You still remember how to find the angle, Nela? Hello, hello. Where is Nela?
Yes, sir.
Do you still remember on how to find the angle there?
Do we just use arctan?
Not necessarily. It's not as simple as that. Because you have to use the method, the triangle method there. Okay, Nela?
Oh, okay, sir.
I think for this particular triangle method, I will explain it tomorrow in order to remind you about this. Okay, in order to remind you about this this kind of geometry. Okay. Now, this one as well, we will discuss the detail about how to solve this tomorrow. But I want to discuss this a little bit, especially on how to draw the free body diagram of this. Okay, Sanwirya. Hello, San.
Yes, sir.
Okay, would you mind to help me on how to draw the free body diagram of this, San? But before that, what is the question first, San?
Let me read the question first. Okay, sir.
Mhm.
Sir, so the stiffness is the constant of the spring, or what, sir?
Yep. Stiffness is the constant of the spring.
Oh, okay. So firstly, we need to find the AX, AY, I think, sir. And then draw
Actually, the first one is supposed to be drawing the free body diagram, right, Sam? Okay, the first thing that we're supposed to do is to draw the free body diagram. And after that, yes, we can find the reaction at support A. And after that, we can find the force at point B due to the spring, right? And after that, we can find the stiffness after we find the force at point B. Okay, so, but before that, we have to draw the free body diagram, right, Sam?
Yes, sir.
Okay. Which free body diagrams I want to draw first, Sam?
I think the beam first.
The beam or the pulley first, in order to solve the force.
Can we just can we draw the? Can I annotate first, sir? Can we draw this part first, sir? Or we have to do it individually?
No. If you draw together or like that, most likely it will be troublesome for you later. And because the problem is, if we draw it that way, we don't know the dimension of the pulley, right? Correct or not?
Oh, yes. Yes, sir.
So the first thing that we're supposed to draw is to solve the things at the pulley first. You want to solve pulley C first or pulley D first?
I think D first.
Okay, D first. Okay,
yeah.
So, but before going for pulley D, it's better to go for pulley E first, right? That's the one that we know, right?
Yeah.
Okay, so at pulley E, we have weight here, 40 kilograms multiplied by G. We assume that G is 10, so 400.
400.
What else do we have?
The tension.
We have two tension, right?
Two tension, yes.
Okay, T1 and T2. Okay, using sigma moment at E equal to 0, we will have T1 equal to T2, right? Because T1 multiplied by R equal to T2 multiplied by R, right? And
yes, sir.
Using sigma Fy equal to 0, we will get that T1 plus T2 equal to 400.
400.
Yeah, right. So T1 plus T2 minus 400 equal to 0. Okay, what we will get is T1 is equal to T2 equal to 200, right, Newton?
Yes, sir.
Okay, that's what we get from the first free body diagram. And now let's draw the second free body diagram. D, pulley D, right?
Yes, sir.
In at pulley D, we will have it like this. Something like this. This is pulley D. What we have here?
Tension on the x-axis.
Tension on x-axis. We call it as T3
T3.
because we haven't solved it yet. What else?
And then T1, T2 as well.
T1, T2. Which way is going?
Going down.
Going down, correct? Because it's action and reaction with this, right?
Yeah.
T1, T2. But here we know already the value equal to 200 Newton, equal to 200 Newton. What else that we have here? Sean?
4D. That means,
Yeah, 40. There's supposed to be pin, right? IT?
oh, yes. So dy, dx.
dy and dx, correct. We have dy there. Okay. So I will put dy here and dx there. Okay. Using sigma moment at d equal to 0, what we will get? Sean. T3,
dy
right?
equals to T1 plus T2.
dy, sigma moment at d. So at the center.
Oh, at the center.
T2 multiplied by R, right? Minus T3 multiplied by R equal to 0, right?
Yeah. Yes, sir.
So what we get is T3 equal to T2 equal to 200, right?
Yeah.
Okay. Now, using sigma Fy equal to 0, what you have there?
Dy equals to T1 plus T2.
Correct. Dy equal to T1 plus T2, which is equal to 200 plus 200.
Yeah, 400.
Equal to 400 Newton. How about dx? Using sigma fx, okay?
Yeah, sigma fx.
Sigma fx equal to 0. Okay.
Dx equals to 200.
Yeah, T3. So dx equal to 200 Newton. So you solve everything there, right? Dx, dy, you solve it. Now, let's go to the pulley C. What you have here? Pulley C.
Pulley C, it's tension first.
Yeah, tension. Which going? Which way is going?
To the right.
To the right. For the one that to the right, it's supposed to be the same as what?
That's the same as T3.
Correct, T3. And
how
about the going slanted towards G? Is there any tension there?
Yes.
Yes, correct. We call it as T4.
T4.
And what else?
Also CX and CY.
CX, CY, correct. CX and CY. CY and CX. Okay, CX and CY is the pin, reaction at the pin. Okay. Now, try to solve it. T3, we already know the value, right? 200 Newton. So, using sigma moment at C equal to 0, what we will get?
T3 times R equal minus T4 times R equals to 0.
So T4 will be equal to T3, right?
Yeah.
Will be equal to 200 Newton. Okay. Now, using sigma Fy equal to 0, what you will have there?
CY.
Minus.
Do we need to, for the T4, we need to make it to the X and Y components or not?
Yes, but you can use it like you can just multiply it directly with the cosinus or sine, right?
Oh yeah.
The angle is 3, 4, 5, right? This one, the triangle is 3, 4, 5. 3, 4, yeah. This one, 3, 4, 5. Okay, when I keep.
Sorry, sir. I think the screen.
Yes, correct. The screen. This one. Okay, 3, 4, 5, like that. Okay, so Cy minus T4, if this one is theta, okay, T4 sine theta, right?
Yeah, sine.
Sine theta. So sine theta is supposed to be 3/5, right? Equal to 0. So Cy minus 200 multiplied by 3/5 equal to 0, right? So Cy is equal to
120.
120, right? Now Cx, the last one. Using sigma fx equal to 0, what you will have there?
T3 minus
Sigma fx equal to 0. T3 minus Cx minus T4 cos theta equal to 0, right? T3 minus T3 is 200. 200 Newton minus Cx minus T4 is 200 as well. Cos theta is what? 4/5, right? Equal to 0.
Yes.
So Cx is equal to 200 minus 200 multiplied by 4/5. So what is that?
160.
160. So 40, right?
So Cx is 40.
Yeah, 40.
Yes.
Now, if you draw the free body diagram at the end, you can draw now, Shan. You can draw the free body diagram of the beam. But what you draw right now is only the reaction force. So this one, AY, AX, and this one is PFPC, FPF, right? From the spring, correct, right, Shan?
Yes.
And
yes.
at C there, you draw Cx and Cy, but the opposite direction. Cy going down, Cx going to the right. And at D, you draw dx and dy now. Okay, dx going down because opposite of what we draw here, and dx going to the right, to the left. Dx to the left, di going down. So this is our final free body diagram right now. Okay.
Yes.
I will re-explain about this tomorrow. Okay, so we will start the discussion of our class tomorrow with this one, and with the previous one, this one about the angle. Okay. I think that's all for today. Okay. See you guys tomorrow morning at 7. Okay. See you guys. Thank you very much.
Thank you, sir.
Yep.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you. Bye.
Sir,
Yes.
for the homework, I accidentally put the wrong name, sir. Is it okay?
You accidentally put the wrong name.
Yeah, I named the file wrong. So it was supposed to be like homework 2 underscore the name, and I just put homework for the title.
But you put your name there, right?
I did put my student ID.
Ah, yeah, it's supposed to be okay.
Okay, thank you, sir.
Yep, yep.